Welcome to this video on the relation between renewable energy technology and circular economy. This relation exists in several ways. First, it is good to mention that the relation between energy consumption, material consumption, and how that affects the metabolism of our society has been for long the study of environmentalists. In this nice overview, several key moments are highlighted in the past 60 years, with names of famous authors and famous titles. And most of the concepts that we discuss in this online learning module are taken from two fields of science: industrial ecology, since 1989, and circular economy, since 2012. In the previous activity, I already discussed the strong link between the introduction of renewable energy technologies and materials. In this video, I would like to deepen that somewhat more with comments about circular economy. And this is best introduced with a so-called butterfly diagram by the Ellen MacArthur Foundation. This graph has a blue and a green side. The green side is all material and energy that we can take from nature and also can return back to nature. The use of a biological feedstock, for example, like corn or wood for renewable energy production, is an example of how renewables can be taken from nature and also given back after use. The other part of the picture, the right part, blue in color, are all human-made products, technologies, artifacts that still need materials from nature, but must be kept in society. For example, metals or plastics, etc. The blue side of the butterfly diagram on the previous slide needs some further development. In the first phase of a product or technology, we can distinguish 6 different strategies to make sure that we do not have to landfill the materials. We can reuse, but also repair, refurbish, remanufacture, repurpose. These strategies can reduce the amount of material that has to go to recycle. And the levels of circularity show us 3 ways in which energy transition and material transition are intertwined. When applied to the renewable energy technologies, and not only the energy supply is renewable, coming from wind, sun or geothermal, but also the materials that are used for the manufacturing of the renewable energy technologies are made in a renewable way. Secondly, by applying the circular economy levels to renewable energy technologies, energy savings can be achieved, because less energy is used for producing the materials, and in that way the energy payback time can be shortened. And the circular economy of consumer products can lead to higher energy consumption per product, because collection and recycling need energy as well. In case this energy that is needed for circular economy comes from renewable energy technology, both the energy cycle and the material cycle can be optimized. In summary, our takeaway is that the principles of circular economy can be applied to renewable energy technologies. And 10 levels of circularity are discussed. And these 10 levels can also act as design principles. The design of circular renewable energy technologies should start with the questions about how to prevent the use of certain critical raw materials, or how to decrease raw materials use per unit of product. Circular renewable energy technologies need a rethinking of how the technology is designed and engineered. In the use phase of, for example, a wind farm, questions should be addressed how to reuse parts of the system, how easy it is to repair, how elements can be refurbished. After dismantling, proper remanufacturing can take place, or even some parts, for example the propeller blades of the wind turbines, can be repurposed. In the next video we will discuss that the application of the R ladder of circularity also needs proper governance of the closed-loop supply chains for energy materials. Thank you for your attention.